Hello class, this is Mr. Shu again, and obviously I'm not in class today, but hopefully today will still be a productive day of review for you. The last 13 minutes of class you've spent working on a probability question from the 1997 exam, in particular question 3. And the reason why I chose this question is because it involves having to construct a tree diagram, and these problems tend to be a struggle for many of you. So hopefully today will be the day that it clicks if it hasn't already. So right now you'll be given the opportunity of watching me work through a question, and then we will look at the answer rubric together, and then you can score your question against my question as well as the answer rubric. So let's get started. A laboratory test for the detection of a certain disease gives a positive result 5% of the time for people who do not have the disease. The test result gives a negative result 3% of the time. 0.3% of the time for people who have the disease. Large-scale studies have shown that the disease occurs in about 2% of the population. What is the probability that a person selected at random would test positive for the disease? Show your work. And part B is, what is the probability that a person selected at random who tests positive for the disease does not have the disease? Show your work. Oh, okay. All right. Cool. So, this is obviously, like I said earlier, a tree diagram question. So what I want to look at right now is the percent of the population that actually has the disease. So if I do this, has disease, and then does not have disease. There's probably a better way of writing that. And the probability of this is 0.02, and this is what, 0.98. And if they have the disease, the probability that it gives a negative result is 0.003. And then a positive result would be 0.997. Now, I think they were being a little bit unreasonably tricky here, but got to be careful. It says 0.3%, then it's, going to be 0.003. And if they don't have the disease, then there's actually, this is kind of high, a 5% chance of a false positive, which means there's a 95% chance that it'll be correctly negative. So the first part of this question is asking, what is the probability that a person selected at random would test positive for the disease? Now, that means testing positive would be this part and this part, right? So the probability that they have the disease and they test positive is going to be 0.02 multiplied by 0.997. And not having the disease, 0.98, and testing positive times 0.05. Okay? And if I take these two probabilities and I add them together, then I will get the proportion of people who test positive, and I think that that's what they're asking for. So let's take a look at this. It would be what? 0.02 times 0.997 plus, was it 0.05 times, oh wait, no, my bad. 0.98, and then false positive is 0.05, I think. Let's just check. I'm getting confused. Yeah. Okay. So then that would be 0.06894. So 0.0689. 0.0689 might as well. Okay, so we're done with part A. So part B, what is the probability that a person selected at random who tests positive for the disease does not have the disease? Okay, so tests positive but does not have. So this is going to be, normally I don't use the formula, but some of you may need it. So if I define, let's say this was going to be conditional probability, right? So probability that they do not have disease given that they test positive. So the probability that they don't have the disease, we're going to have to do probability that they don't have intersect test positive over over the probability that they, test positive. Okay? And since we already have the probability that they test positive, that's 0.06894, all we need to do is find the probability that they don't have the disease and they test positive. So that means this is what, 0.98 times 0.05, right? And so if we go to our calculator, we go 0.98 times 0.05. We take that and divide it by 0.06894. And we get 7108. 7108. Okay. So this means that out of the people who test positive, about 71% of the people don't have the disease, which means this test is not as accurate as we would like it to be, because out of the positive results that come out, 71% of them are false positives. Obviously, this is assuming that we did this question correctly. So let's take a look at the answer rubric together, and then you can score this on your own. So this is kind of an old rubric. This is the oldest rubric that I have, and it's different than all of the other ones, possibly because this was the first exam. So here it says the complete response, like 4 out of 4, is that either by formula or by constructing a table or tree diagram demonstrates understanding of the 3 pieces of information given in the problem. Positive, given no disease, 0.05, negative, given disease, 0.003, and probability of disease, which is 0.02. Uh-oh. Okay. So let's look at part A. Correctly reworks that conditional information to answer the unconditional probability as probability positive is equal to probability of disease times probability of positive given disease plus probability no disease times probability positive given no disease. Okay, so this is what we got. Never mind. Sorry, I misunderstood that. Okay, so that's part A, 0.0689, which it looks like we would get full credit here. And then B, correctly reworks the conditional information to answer the conditional probability as probability no disease given positive is equal to probability of positive given no disease times probability of no disease over probability of positive. Okay, and that's exactly what we did, 0.05 times 0.98 over 0.0689, which is equal to 0.7112. You're allowed to have minor arithmetic or decimal conversions, but the reasoning is correct throughout, and the following tree diagram or table may be used to show the structure of the problem. So this is, so it's similar to what we did. I don't think we wrote these probabilities in, but I don't think that matters that much. Okay, or you could have done a two-way table. This would also work. So let's see what a substantial response would be. This rubric is not nearly as clear as rubrics that were developed later, obviously, because this was the first one. So a substantial response here says either by formula or by constructing a table or a tree diagram demonstrates understanding of the three pieces of information given in the problem, reasons through both parts correctly, but may have misread the data in the problem or have errors in arithmetic. Example, correctly reasons through part A and uses the results in the denominator for the solution to part B, but uses incorrect product in the numerator. Okay, so as in your denominator is fine in part B, but your numerator is not correct. And then a 2 would be A or B is correct, but the other one is not, and so you would get a 2. And then a 1 is showing some understanding. I think that's kind of vague, but I guess they give an example, understands the conditional information and attempts to find it, but is probably wrong. So yeah. So hopefully that was helpful for you guys, and that's all I have for you today. See ya.